if you're here for the first time, also in the video description, there are links for GitHub repository where you can try the source code by yourself. And there you will also find the links for community support and all reference we are using through the course. Please, if you find this useful, share with other devs. And also tick the bell to receive notifications about new modules. If you have any question, please reach out in the Discord server or you can also ask in the Stack Overflow. This is an example of module 2. We had this piece of code to understand how querying pattern matching works on PureScript. Let's try to improve this code a little bit, and in this case, I want to change the welcome function to allow the function to receive not only ints like here, but I would like to build a new feature that allows us to change this int value for something else. Like we know algebraic data types, right? So what if we build a type that represents the module number, and we have like many constructors on for each module, for example. So instead of 3, for example, what if we had like a type called module, and in its type constructor we had like third instead of 3, like here. So with that we could like allow more resilient API interface that is not gonna try to transform into to other things. So it's an improvement in that perspective. So how we could do that? So let's see. Here's the output. We have this. Just to remember, we have this main function, and this function is logging in the console the output of this welcome tick3 append together. So this returns a string, right? Append together with welcome tick4, and this welcome tick is receive this n, which is the number, append a new line to the returning of the welcome function with the welcome text, welcome to the, and of course being Bluetooth experience. And so we pass to the welcome function the first argument, the second argument there, and the n value as the third argument. So welcome and receive the string int, right? And then we have this output. So welcome to the third module of experience. Welcome to the invalid module in the second case, because we are passing 4 and we don't have a 4 value because we are not we still don't have the 4 module here. We still don't have the 4 module, so I placed this otherwise invalid here value for the 41. Just an example how we could pattern matching against the value of this int, so to represent the invalid value. Okay, let's try to keep the thing the same thing and do a small improvement that allow us to change this number for algebraic data type. How that could be. So here we have the factory code with type class, because we're gonna need type class to do that. And the reason we need to have type class is because, as you can see here, the welcome, everything else is the same. Welcome tick here now receives third, as I said, and third is the type constructor of algebraic data type called module, right? And we append together to prove that this is like a new feature and not still supporting the old scenario where we had like a number. The welcome tick4 is still being supported here, and we have a append operation on the string, so everything the same. Here just added the type signature. And you can see there's something different here in the welcome. The welcome, the implementation, the function implementation is the same, so it receives n, and appends a new line and the return of the welcome function, and we add this n here with the same thing. And this n now can be uh, a module or can be an int value, right? Because we're passing third here and 4 here. So because we're passing third and 4, we call this a polymorphic value. And this polymorphic value we need to use for our keyword to define them. So this is like a variable or a placeholder or a hold that allow us to define uh, anything in place of this here. So for all means that this e can be anything, not only int as before, right? If you remember the previous example, in this n we just had the int value, and now we can have module and also int. So because we can have module and int, I need to uh, change the int value to something polymorphic, and this is the reason because we have for all. So for all allow us to create this polymorphic type here. Okay, and I'll explain what is this. You don't need to learn about this right now. Let's just move forward with the knowledge that we have so far. Um, so welcome here is the function, and we have the same thing here, like in the function implementation, almost the same. We received 3 arguments here, w, n, and m. And as before, we have string for the first argument, string for the second argument. And in place of that int, as before, we have this polymorphic type, e. So this is a polymorphic type, as you can see, right? And we again have this show e that I explained very briefly. Don't need to worry about this right now. Let's move on. Let m, so we create this mtick, and now we're gonna use this show function. And this show function, we saw this function before, but what does this function do? If you take a look at this show function, you're gonna see, okay, this function is receive this m, right? And what is this m? If you take a look here in the argument, you're gonna see, okay, this m is this e. And what is this e? It depends. It depends on the context. So it can be a module or it can be an int value, right? So we need to create a function that that has this polymorphic value for polymorphic type for the e value here. Okay, so we need to have 2 functions. One that receives um, an int, and another one that receives a module, right? If you have just int, we need to have a function that handles int. If you had just um, um, a module, we need to have an implementation function that handles the int value. How we can build just a single function that do everything? We're gonna need some kind of abstraction in the language that allow us to overload the same function, you know? So when we need to overload the function in pure script context, we're gonna always use, there are two kinds of solutions for that. We're gonna need to use algebraic data type to handle this in the value level. There's a solution for that. But there's another solution that's a lot easier to implement. That is just creating um, the type class. So what is a type class? As you can see, we have this class keyword here, and we define the class name, which is show right here, okay? And a class should always have the uppercase first letter, so it should always be camel case. We have some class here definition, and we could just declare this class, but we can also attach to this class some function signature. So for example, this class, we say that this class has the show member with this type signature. I know that if you're coming from OOP world, you're probably gonna be biased to understand this as a class. OOP can be used to explain type class, but can be used to implement type classes. Okay, that's OOP class are strictly not the same thing as type class. This is like there are more things on OOP class than just type class. Okay, so OOP goes beyond type class. But it's a good analogy, but you should not strictly with that. You should understand that, okay, there are different things. Because type class is just a part of what is a OOP class. Okay, you cannot do everything that you can do in OOP class. So it's not strictly speaking what is a type class. Okay. So, but in type class we also have the members. Okay, and the members are need to be functions. Okay, I mean it should be it should have type signatures. So each member has a type signature. So in this case, show has the type signature. Okay, and so we create the member show. So what it means, you can see that we have a e here, which is our polymorphic value, as we have this e here. So it magically allow us. It is not magic. I'm gonna show that. I'm gonna show you that. But having this e here allow us to use show with anything in place of this e. Okay, so if I want to show a string, it would be okay. If I want to show a module, it's gonna be okay. If I'm gonna show an int value, it should be allowed because the compiler is gonna see, okay, there's a type class that has show member, and this show member is a polymorphic value on the first argument. So I should allow this function to be called that way. Okay. But to do that, to tell to the compiler to look for a type class for something, you need to use that one thing that we call the constraint. You also need to define the show constraint here in the function to tell to the compiler you're gonna use the member function from the type class. So in this case, we are using show with m, and as we know, this m is this e. So I add a constraint here showing that we depend the show type class instance for this given e polymorphic. Because we are adding the constraint here at show e, and we know that e is the same as the m value here. We'll allow it to call show with this given. I could also use a constraint in a type, any type here. I could also like have show int here and use int here. It would work the same way. The compiler will try to find an instance for the int type, and with that instance call the given function. So the instance is actually the function implementation. So for one side, the class member is just a type signature of a future function. So in OOP terms, is more like an interface. You know, you define how the function will work, and the type is gonna be used for that. And the instance on the other side is the implementation of that given type. So in this case, we have instance for both int and module, okay, for the show type class. And the way that we declare an instance is the same way we declare a type class. So we just change the class term to instance, use the same type class name, and place here the type. So what we are doing here is building a show function, a polymorphic or overloaded show function that works both for module type and int type. And the way that we abstract over both is with the type class. And whenever we're going to use this, we need to constrain here to tell to the compiler, okay, I should look for the type class for that type, for that given type. In this case, it's polymorphic value. So it means that int and module fulfill this. And how the compiler you figure out that, okay, I need to have an instance for module and another for int, only by usage. So for example, here we are using welcome with third type constructor and for, right? And we know that the type for third is the module, and the type for is the int. So because we know that type for third is module and the type for is int, the compiler also knows that welcome tick is gonna handle both values. Okay, so this for all in this sense becomes more restricted only to module and int. So the compiler is gonna look for instance for module and int because we are using welcome with only with module and int. So this means that if we add a new value here in this welcome function, like a new type, a new value for a new type, like for example string, and we try to call welcome with that string, the compiler will not throw that I should pass module int. The compiler actually will throw that we need to have instance strings, show strings, because we are using welcome tick with a given string. And there's another thing, because we have this polymorphic value here and we have this constraint here. If we don't pass the show, this constraint here, the compiler will also warn you that probably it's gonna throw because if you think about that, it's not all E for all E that has an instance for type class show E. If we remove this show E here, if we remove this and try to call welcome tick without that, we're gonna have an error. And the reason is we would pass values that don't actually have instance for show here. The compiler will show you that we need to have the same E for here should be the same E for here. So because this E has a constraint here, this E should also have this constraint. Let's see the output for that. It's the same thing, right? The M here, so is being the result from this show on M, and this M, as we know, is module or int. So this show is gonna convert that E to a string by this type class here, member show. And we can see the implementation. So if you call, like in this first example, third here, the compiler will figure out which instance gonna use. So in this case, it's gonna be the instance for module because we are passing the third type constructor for module. So you're gonna look for show module, and they find that, and you're gonna use this instance instead of that one. So it's gonna figure out, okay, this is the one that you're looking for. So let's show with that. So they're gonna use now pattern matching with that third type constructor, and we show the correct expected string third here. Okay. And in case of for, so if you call welcome with the old API for, now our welcome function will receive an int value, not a module, and if you compile, we figure out, okay, this you're looking for the instance for show for int. You're gonna pattern matching against this line here, and gonna find, okay, this is the for one, so let's call show. So this is gonna figure out what is the show for the fourth now. So, and we know that 40 is a module, so he's gonna look for the instance for show on module, so this one, and gonna pattern match against this line here, and gonna show 40 here. So we are reusing this instance inside of this instance. This is to show you that you can reuse instance functions in also another instance. You can reuse instance that way. So this is a very powerful feature of the language that allows us to add polymorphic types and also overload functions parameters using this feature. Let's see the output if it's the same, right? We expect to have the welcome for third, the welcome for four here. So welcome to the third module of Fruits Experience, and welcome for the fourth module. We append them together, and we have in line here.